Hello, and welcome to AMD's booth at SC21. My name is Matt Demas with GigaIO, and I'm here to talk about bringing cloud flexibility to the on-premise data center. The growth in data has brought a lot of challenges to the data center. Companies today are trying to go take advantage of all this new data in things like new products, new services, new advertising capabilities. In order to go work the AI workflows with this new data, they need things like GPUs and FPGAs, vector engines, DPUs, that traditional data center is not equipped to go handle this. So most data centers have gone to the cloud and said, hey, I'm going to use cloud flexibility, their ability to give me unique hardware profiles whenever I need it, and provides true software-defined hardware to go solve this problem. The cloud has been able to give them unique server profiles to go solve exactly what they needed when they needed to go do it. The challenge with them has been the performance and the cost. So when I'm running inside the cloud, I don't have that same performance because I could have servers in one location, other servers in another location that all need to be talking to each other. The cloud doesn't care. It gave you two servers. The other challenge you can run into is I have things like egress fees, and cost per GPU is significantly higher than it would be to just buy it in your own data center. But if I put it in my own data center, I'm stuck in a scenario where I bought a server that has 8 GPUs in it. When I only need 1, I may be wasting 7. Or if I bought servers with 2 GPUs and I need 4, I have to go buy a whole nother system to go run that job. The uniqueness of all this, the AI workflows, cause a very significant challenge when you're talking about processing this data in your traditional data center. Here's a slide comparing the difference between the public cloud and your on-premise data center. As you can see, flexible configuration options is a huge value of the public cloud. The ability to scale those nodes out on demand. But with that comes cost. I have physical costs that I have to pay every month, and then I also have the cost of performance. When I'm scaling these systems out and they could be distributed worldwide, I never know what kind of run I'm going to get on that workload. It could come in hours, it can come in days. I have to pay for that. So on the on-premise environment, I've set a physical hardware environment up that can optimize for performance, but I'm very defined by what my hardware profiles look like. It all fits inside sheet metal. Whatever's in that sheet metal is what that workload's going to get. So I have to then change my software to fit that hardware profile. That may not be the best thing for my data. The question is, how do we bring both the flexibility and the cost savings with performance together for your on-premise data center? So enter GigaIO's Fabrics environment. What Fabrics is a PCIe native switching platform. PCIe is what all these devices communicate across today. It is the backbone of today's servers. Now the difference being is instead of everything having to fit inside of a PCIe slot inside the server, we're going to disaggregate all those devices into pools. Now every server has access to whatever devices I want whenever they need them. So I'm no longer confined to what fits inside the server, what happens to be inside that server today. I can literally define what my server looks like on demand. So that's called server composition. So I'm able to go give a server, say, 4 FPGAs or maybe 8 MI100 GPUs from AMD. I'm able to then, at the same time, deliver it the right amount of storage it needs to run that job, maybe even some extra networking. Now, the other side of what Fabrics can do is we can also provide a high-speed interconnect, ultra-low latency between those nodes. So if I have multiple nodes that are all given an accelerator and I want them to all work together, they can all do that over the Fabrics memory ring. The internode communication allows us to run things like GPU direct RDMA or across our libfabric interfaces. We can run our MPI traffic across that. So it allows us to offload that from either existing high-speed interconnects or emulate existing high-speed interconnects in scenarios that environments don't have those today. So in short, Fabrics has set up an environment where it allows data centers to take full advantage of what AI offers with all this new data, while providing cloud flexibility and lowering your overall spend in the environment because it gives you the ability to dynamically configure those servers with the right resource for the right job. Physically, here's how it's set up. So we have PCIe switches. These look like Ethernet switches, but these are actually native PCIe, the same thing that's in the back of your servers. These servers interconnect together. From there, connect our servers into that. So these are AMD Gen 3 Epics. From there, we're going to go add our accelerator pooling appliances. These can hold anything. For example, this one's holding a set of MI100s from AMD. We have another accelerator pooling appliance sitting here next to it. Now, we also have storage pooling appliances, and we also have storage servers. This gives you the option to pick and choose. Do I want entire drives mounted directly to my servers, or do I want to go create VLANs where I take sections of those drives and connect them in for the exact right amount of storage space I need to go run the workload? And all this is configured with an API. So when I go run the job, it gives those servers exactly what they need to go run what they want to do. Lastly, we're going to go talk about our memory pooling appliance. This gives servers the ability to have access into additional memory it doesn't have inside of its server. It also allows servers to share memory and access the same memory simultaneously. So if I have memory bound applications, I can go expand what that server has with a simple API. Now, I want to talk to you about how this works in the real world. Universities have a very challenging job if they have lots of schools of business. These schools of business have to be able to be supported by their central IT environments. So today you're going to look at mechanical engineering. Mechanical engineering needs FP32 GPUs, vector engines to go run due to CAD drawings, digital twinning, lots of different new things that it's trying to do to help reduce costs of what it costs to manufacture new products. Then you're going to look at your bioinformatics, where they want to do traditional AI workflows with FP64 training GPUs and FP16 inferencing cards. Inside your computer science, I could do lots of different things. Some require FPGAs or best suited with FPGAs. Some are looking just FP16 GPUs. Lots of different options for different schools of business. So how does central IT plan for this? Do they build a system out for every school of business? Or do they build one bigger system that's going to cost significantly less overall, but allow for the flexibility for the school of business to come in and go build exactly what they want when they want it? Give truly software-defined hardware with their on-prem resources. So you'll see here, mechanical engineering is able to go build a system that has 3 of these FP32 GPUs in them. In this case, it'd be the MI100s running inside these servers. And then when bioinformatics comes in, they're going to go, hey, I need 3. And I want to have 4 FP64 GPUs in each one of them to run this training workload. When they did that, they were able to go create 3 separate systems that are unique from each other. Each have their own local storage and their own local GPUs, but now they're all able to intercommunicate across the fabric's memory ring. So they can operate as one big unit that has 12 GPUs inside, even though I composed 4 GPUs to 3 discrete servers. And you'll see something very similar with the computer science team. Some of the big advantages are we have pay-as-you-grow capability. So if I want to add more GPUs later, I can do that. If I want to go try new GPUs, I can add them into the fabric. I don't have to buy new servers with these new GPUs inside them. Instead, I get to go just add the resources I need when I need to. I can replace those resources when it makes the most sense. Replace servers when it's time to replace servers. GPUs when GPU storage for storage. I can also do pretty incredible things like compose 32 double-wide GPUs to a single server. Things that are unheard of today. Here we've done the exact thing that we talked about. UT needed this to go support multiple schools of business, and so they chose GigaIO's composability fabric to be able to do exactly that. So partner with AMD and their EPYC Gen 3 CPUs running on Dell servers. We've set an environment up where they're running vector engines, FPGAs, GPUs in the same infrastructure, the right resource to the right customer at the right time. If you have any more questions, please contact us at gigaio.com. Thank you.